guys ready? Let's begin. Today's agenda is the big question. We're going to begin by asking you this question about a specific topic that I got there for you. Then we're going to watch a video about light, okay? Now you kind of know what we're going to talk about. We got the keywords. We're going to work page 122 and page 123. We're going to do some light worksheets as well. So please, let's get ready to begin. Are you guys ready? Okay, let's begin. How fast can the light travel? How fast can the light travel? Have you ever thought about that? How fast, when you turn on your light in your bedroom, in the bathroom, in the living room, how fast does it turn on? Immediately, or does it take very, very long time? Okay, I'll leave that question for you. Very good. Now, I want you to please pay close attention to this video about how light is produced, okay? We have many ways of producing light. There is natural light and man-made light. I'd like to invite you guys to watch this video here and pay close attention so that you guys learn about electricity or light, okay, in this case. All right, please pay close attention.
Light. We need light to see things. Sun is the only natural source of light. We get heat and light from it. All others are man-made or indirect sources of light. Some of them use fuel such as coal, gas, oil, and wood, while some use electricity. Objects that produce light are called luminous objects. Objects that do not produce light are called non-luminous objects. We can see non-luminous objects only when light falls on them. Did you know that light always travels in straight lines? Light can go in all directions from its source, but it goes in straight lines in all those directions. A shadow is formed only when an object blocks the path of light. A shadow is always formed on the opposite side of the light source. Now, you know that you should not be scared of your shadow, as it means that there is light somewhere near you.
Alright guys, I have a question for you. Did you like the video? Did you enjoy it? Okay, here we go. It is important that you guys know where the light comes from. And now we're talking about light. We're going to read this key about Curie's scientist. This is called Speed of Light. And I would like to invite you to read it with me as I go. The first concept we're going to work with, it's called speed of light. What is the speed of light? Light is one of the most important factors for sustaining life. Without it, objects will not be visible and plants would die. Remember that we talk about how plants get energy before getting out of class. And plants get energy from the sunlight, okay, to produce their photosynthesis. Now, so it is very important not only for humans to get light, but also for plants and for animals, okay? Now, most light comes from the sun. How long do you think it takes for light to travel from the sun to Earth? Do you think it's a short journey or a long journey? Okay, I'll leave that question open for you. Light takes time to move from one place to another. However, we do not notice it because the fastest speed in the universe is the speed of light. So imagine one of the most natural, fast thing is light. In fact, light is so fast that it could go around the Earth 7.5 times in just 1 second. What do you know about speed? Now let's check this here. Speed. However, nothing matches the speed of light. Light travels at 299,792,458 miles per second. Sunlight reaches the Earth in 8 minutes and 19 seconds. It's not that fast, but it's not that slow. 8 minutes to receive the light to your houses from the sun. Now, what is speed? Speed is the distance that an object covers in a certain amount of time. So this is how we measure speed, by the distance, okay? Now, Usain Bolt, who is this person? Usain Bolt is the world record in 100 meters race. He completed it in 9.58 seconds, running at a speed of 10.44 meters per second. Okay, so imagine he's very, very fast, okay, and he made a record. What is Helios? Helios, okay, is the fastest object that was man-made, okay, and this was a German spacecraft, okay. It is the fastest object that exists so far. It reached the speed of 19,505.556 miles per second. Can you believe that? That is a super fast man-made object. Everything in the universe changes under different physical conditions. Light is a type of energy and it behaves differently in empty spaces or in a thicker medium, such as air or water. Do you think that light changes its speed according to the surrounding physical conditions? For example, if I put a glass of water in an empty glass of water, do you think light is going to get faster into the empty glass of water or into the glass that has water? What do you guys think? Okay, let's find out a little bit more about it. The speed of light is always the same in a vacuum. A vacuum is a completely empty space. So I already answered the question. Yes, it travels faster in an empty space, okay? Now, light moves in a slower speed in an Earth atmosphere than it does in a vacuum. It moves even slower when it travels through water, okay? The space between our planet and the sun is a vacuum. There is no liquid, water, or enough particles to make light slower, so it is a complete space and the light goes directly to the solar system. Now, the one that gets closer to the sun, that receives, okay, sun rays faster, it's Mercury. It receives light in just 3 minutes and 13 seconds. The second one, okay, that receives after Earth closer, okay, in closer time, it's in a shorter time, sorry, it's 12 minutes and 40 seconds, and this is Mars, okay. And another one that's very, very far, I would like to say, from the sun, and it receives sunlight in 4 hours and 9 minutes and 58 seconds to reach Neptune sunlight to this planet. So imagine how far away this is, okay? And I think this is the darkest one, I would like to say. Now let's read more about light. The light that comes through your classroom window, it travels for over 8 minutes from the sun. But the light from the stars in the outer space travel for years. When you look at a star, you are seeing light that was emitted many years ago. Wow, that is something very, very unbelievable. Now, I would like you guys to pay close attention to the vocabulary word treasure. And please repeat as we go.
Around, around, around. Highest speed, highest speed. highest speed, outer space, outer space, outer space, to travel, to travel, to travel, vacuum, vacuum, vacuum.
Alright, I really hope that you enjoyed today's key and that you guys learned something new. Don't forget that sunlight travels 8 minutes, okay, to get to the earth. Okay, so it's not that far. I think it's not that long time as Neptune. Neptune is 4 hours away. Um, to get sunlight, okay? And remember, we need sunlight to live, not only us but the plants as well. All right, guys, very good. Let's continue with our activities. What are the keywords that we're going to work with right before we continue working with our book? It says the first keyword is pass through. Go to a place for only a short period of time before continuing. For example, if I go to the supermarket and I visit the groceries section and I go to the cookies section and I do not stop in the cookies section, I just pass through. All right, reflection. The image of something in a mirror, and it can be in a mirror and it can also be in water. Okay, the reflection is the same. It's what you guys see when you look at yourself in the mirror. It's a reflection. You may also use this in water. Okay, you may see your reflection. Speed light. The distance light can travel in a unit of time through a given substance. For example, we mentioned the speed light key, and it was about how much time it takes for the sun to give light to Earth. And remember, it takes 8 minutes. So this is a great example of a speed light. Remember, speed light is the fastest thing in Earth. So it's really fast, okay? There is nothing such as speed light, okay? There's nothing faster than that. And it can be natural or it can be man-made, but it's still very, very fast. Okay, let me invite you guys to open your book to page 122. And this is page 122. This is Curious Scientist. And the big question is, how fast can light travel? Now you know the answer after we read the key, right? Light can travel very slow or very fast. Yes, light can travel in a very fast speed. Very, very fast. Okay, now the keywords we already went over: pass through, reflection, and speed of light. Pass through, something very fast, okay? All right, let's do number 1 together. And it says, read the key and text, answer the following questions. All you have to do is read this green section there, and after you guys read it, you are going to answer the questions that are on 1 through 5, okay, on activity number 1. Now, I'm gonna give you guys 5 minutes. Do you think you need more time? Maybe 10 minutes for you guys to complete this activity. Do you think 5 or 10? Okay, I'll give you 5 minutes. I think 5 minutes is enough for you guys to complete this activity. And after the 5 minutes, we're going to discuss and read together a little bit more about it. 122. And what you guys are going to do is answer activity number 1. But before answering activity number 1, I hope that you guys had the chance to read the green section there, where it's giving us information about light and how fast it travels. All right, let's read it together. Light is it's all around us and travels faster than anything else in our universe. It has many unique properties depending on the source of light and object it comes in contact with. It can act in the following ways. So it has unique properties, and depending on the source of light and object it gets in contact, it acts very different. Okay, it's not the same as if I put it in a glass of water. Okay, it doesn't act the same in a glass than if I put it in a translucent object. Okay, so let's begin by reading details about it. Absorb, taken into the object. Okay, when you put a light into the object, it can be absorbed. Reflect, bounce it off the object at an angle. Okay, it makes a reflection. Scattered, bounce off the object in many different directions. Okay, it doesn't stay in a place. Okay, let's say this is a container, the light goes all over. Okay, it's scattered in different directions. Then we got refracted, some absorbed into the object and some may be bent in other directions. Okay, now don't worry if you do not completely understand it. We're going to go step by step over this light topic in a few minutes. You will understand a little bit more about it as we continue with the lesson. Okay, now let's begin by reading more about it. Light can come in contact with the following types of objects. Transparent objects are something we can see through and easily the light passes through, okay, and completely passes through, such as a drinking glass or a glass window. For example, this one here, light passes through immediately. Okay, you can see that this object is completely transparent. Okay, now then we have translucent objects that are something we can see through but not entirely. Light does not pass through them completely, such as a facial tissue or a window curtain. Okay, so this, for example, I would like to say, I don't have well, I do have a tissue. It would be something like cloth. Okay, for example, or I would like to use this little cloth one that I have here, and light does passes through but not completely. Okay, now it can be any type of cloth, even your clothes. You can use that one to see that is translucent. Then we have opaque objects, or things we cannot see through because light does not pass through them, such as a piece of cardboard or a rock. And I have this glass here. This is plastic, and you may not see through this one as you guys see through this one. There is a big difference. This one is a transparent object, okay, and this one is an opaque object. You cannot see through this. If I put Coke in here, you guys are not able to see it. But if I put Coke in this glass, you guys are able to see it. Now, remember, translucent are those clothes that you may see through them, okay? And I'm using this one to erase our board, but yes, you get some examples, maybe a curtain, something that is not completely opaque, but it's not completely transparent. Okay, let's continue. Even have you ever wondered why you can see through reflection in a mirror? When light reflected off your body and strikes on a surface that is smooth, such as a mirror, the light bounces off at equal angles, okay, and allows you to see your figure. That the rays that travel and reach the mirror are called incandescent rays. The rays that are reflected off the mirror and travel away are called reflected rays. So there are two types of rays here. The reflected rays, okay, that are the ones that reflect on the mirror, and the ones that are not reflected, okay. These are the rays that bounce off, okay, into a smooth area. For example, as I mentioned, in the water, okay, you may see yourself there because you get light into your body and you reflect it on the water. Okay, another example. Let's see. Let's begin by reading the text and answering the following questions. So we already read the text. Now we're going to answer the questions. Are you guys ready? Let's answer number one. Describe one of the properties of light. What is something that light has as a specific property? It can be what? So number one, it's yes, it can be easily observed. It can be easily observed, okay? Even if it's, it can be observed by a glass of water, for example, or it can be observed into a completely empty water or a vacuum, okay? What is the kind of object that light passes through? What is this type of object? And we mentioned a glass of water that was transparent, okay? So transparent. In a curtain, what is this specific situation with curtains? Oh yes, they are translucent. Translucent objects, okay? This is a curtain in a glass of water. You may see through them, okay? These objects are not opaque and they are not transparent, so they are translucent, okay? They're like half. Okay, and number three says, define opaque objects. What is something opaque? And as I give you the example here, this is opaque and this is a complete transparent one. So how can you describe this? How can you describe it? What is an opaque object? Number three, things we cannot see through, okay? So this is things we can't, I'm gonna erase this here, see through. Things we cannot see through, such as a plastic glass, for example, okay? Cardboard, okay, and rocks. We cannot see through those, okay? Number four, why can we see our reflection in a mirror? It depends on the, very good, it depends on the light. So light bounces off the mirror. And what happens after it bounces off the mirror? And goes at different or equal angles. So this is you here. This is the mirror, and this is you guys. This is the reflection, right? Now, the light bounces off the mirror, and that's how you guys get your reflection. Number five, what is the name of the rays that each mirror, that reaches a mirror, sorry? It's at the bottom, it's called what? It starts with I. Yes, incident. Incident rays. These are the rays that get into the mirror and you guys, so that you guys can get reflected. Okay, so far we know that light can be absorbed by any object, okay? Light can be seen by a transparent object or by a translucent object. Now, things we can't see through are called opaque, and we have here an example of an opaque object. Light bounces off a mirror and goes at equal angles, okay? That is how you guys reflect on a mirror. And incident rays are the rays that get in the mirror so that you guys can reflect easily. All right, I would like to invite you guys to pay close attention to this worksheet that I have here, and it's called light. Okay, let's do number one. The first one is an animal, okay? And this is a light bug. And do they get their own light? Yes, it's natural. The moon gets its own light? No, it gets light from the sun. The sun gets its own light? Yes, it does. A cell phone, does it get its own light? No, you need energy to get it on. Coins get their own light? No, you need electricity or a light bulb to light it up. A light bulb gets its own light? No, very good. A light bulb needs electricity as well. A pen gets its own light? In its batteries, maybe. Okay, so no. A diamond? Yes, a diamond can shine through the reflections of the sun, so it doesn't get its own light. How about this light bulb that we have here, the ancient ones? You need gas, so no. A chicken gets its own light? A chicken doesn't get light at all. A light bulb, does it get its own light? You need electricity or you need batteries, the same. Glasses, do they get sunlight? No, you see with the rays of the sun. A star, does it get its own light? Yes, a star, yes. Remember, it takes thousands of years, for a star to get its light. And finally, we got a candle. Does it get its own light? No, it doesn't produce light. You need a match to turn on the candle. So these are the three objects that produces their own light, okay? Now, go to page 123, and I'm going to erase page 122. Page 123. And I would like to invite you guys to take a look at the page and read as much as you can from that page. I'm going to use my marker, and this is page 123. In page 123, you guys are going to describe the characteristics of each kind of object and how light interacts with them. For example, number one would say transparent objects. What are transparent objects and how light interacts with transparent objects, like this one here, okay? It's completely transparent, you can see through it. Translucent objects, how does translucent objects like a cloth, okay, how does this, what are the characteristics and how does light interacts with them? The last one is opaque objects, and this is not transparent, not translucent, and you cannot see through it. So write down the characteristics as well. After you guys finish, we're going to check together. If you want to give me some examples here in the transparent objects, in the translucent objects, and opaque objects, you may do so. You may give me some examples there. Okay guys, I will give you 5 minutes for you to complete this page activity. This is page 123. Remember, try to describe as much as you can, okay, each characteristic, okay, give details, and if you want to give me examples, I will accept them too. Let's check them in a few minutes. Enjoy your 5 minutes, please, and try to work as much as you can on that page. Okay, so we're checking page 123, and this is going to be activity number 2. In activity number 2 says transparent objects. What are some transparent objects? And remember, I gave you this example here for transparent objects, and I'm going to write transparent objects. What are the characteristics of these objects? What do you have? Tell me, come on. Yes, you can, or these are things that you can easily see through. Okay, for example, I would say a window, a glass, okay, a glass, and another transparent object is water, okay, that is water, something transparent, something that you can easily see through. All right, and a translucent, what is a translucent object, and what are their its characteristics? Translucent objects, what are their characteristics? Come on, tell me. Very good. We can, these are things you can see through, but not 100%. That means it's not very, very clear, not completely. Not completely, okay, not completely. And in an example they are giving us is what? They mention a curtain. Curtains, what else? What would be another example for that one? A tissue, okay, clothes. You may see through them, but not 100%, okay? It's not completely clear. That is a translucent. Then we have an opaque object. What is an opaque? An opaque object. Can you give me details about it? What is an opaque object? I gave you this one. How can you describe it? Can you see through this? Is this transparent? No. So an opaque object are things you can't see through. You can't see through, okay? You're not able to see through this. No matter what you do, you still cannot see through. And what are some examples that you guys could use here? You could use rocks, plastics, okay? What else? What would be another one? And cardboard. Cardboard, it's not easily see through. So these are the characteristics. Transparent objects, things that you can easily see through, like my glass here. Translucent objects, things that you can see through, but not 100%. It's not completely clear, okay? Opaque objects, things that you can see through, like rocks, plastics, or cardboard. Even a wall is not something transparent, it's opaque, okay? Opaque, sorry. Okay, so these are this is activity number 4, the answers that you could possibly have. And then let's check activity number 4, number 3, sorry, what you guys have to do on that activity number 3. On activity number 3 says, work with a classmate to compare the following activity. Gather a drinking glass, piece of tissue paper, okay, a cardboard, and a flashlight. So you guys are going to get a glass, okay, a transparent glass, a cardboard, and it can even be a paper, okay, and you can get a tissue paper. Now if you don't have tissue paper, you may use cloth, okay? If you have a cloth, something like made out of cotton, okay? And then I don't have a light bulb, but if you have a light bulb, you can actually light it up and see, okay, and see how light passes through each object. And I'm gonna use my phone's light just to check one example, okay? Just give me a few minutes to check. Okay, so I got here my light, and let's start by first a piece of tissue paper, and I have here a tissue paper that I'm going to use. And here you guys can see it's not completely transparent, okay? You can see the light, but it's not completely transparent. Now, on the next one it says a cardboard. This is a cardboard. It's made out of carton, and you can't really see through this one, right? No, you can't see the light that much. How about this one? This is an opaque object. Can you really see the light through this one? Not that much. And finally, we have this one. Now, can you see the light through this glass? Completely, right? This is a transparent object. Now, if you want to try this at home with the objects that you could possibly have, you may try to do that experiment at home. It's very simple. All you have to do is just check and make sure that the information is here, that the description that are here are exactly the same in real life. So if you want to check them, you may do so. All right, now it's time to check this activity. Here is transparent, translucent, and opaque objects. All of these are classifications of how does light goes through. The transparent one lets all light pass through, and you got a window, a glass there, okay, a lens. You also have glasses to see, okay. You have a light bulb there as well, which is completely transparent, so to let the light pass through and you guys can see. You have a glass of water as well. Now, the translucent objects let some light pass through. It's not completely, it's not 100% clear, but it's some light, okay? You have a leaf there. You can see some light through it. You also have a cotton clothes, okay? You have a tissue, sunglasses, and paper. These are examples of translucent objects. Opaque objects let no light to pass through. For example, a piece of wood, okay? A leather bag, a door, okay? This is a wooden door. A book can also be an opaque object. And a spoon, okay? Those are the great examples for opaque objects. All right, I really hope this was clear for you guys to understand these three classifications of objects that can be seen through light, or light can be seen through these objects, okay? So thank you very much for your attention on this activity. You do not need to write this activity. Do not copy it as well. Okay, so here we go. Now, don't forget that light can be one of the fastest things in the universe. It's very fast, okay? And also there are objects that light can pass through, and it is classified as three things: transparent, translucent, and opaque objects, okay? It's very simple to classify them, and it's very simple to identify them as well. Remember that for the sun to get to earth, it only takes 8 minutes to travel that light, okay, from the sun to your window, okay, to earth. So it's pretty fast, okay, one of the fastest things. And I really hope that you guys enjoyed this lesson about light. Guys, I have to say goodbye now. You did a sensational work today. Thank you very much for watching, listening, participating as well, and trying. Thank you so much. Have a wonderful rest of your day. Goodbye. See you tomorrow, guys.